So to check the error of the latitude and the departure, all we need to do is add all of these distances so we can get the error in our latitude. So we have 355.69 meters plus negative 47.641 meters plus negative 443.683 meters plus 127.507 meters, and this will give us negative 8.127 meters. And as for the error in our departure, all we need to do is add these distances here. So we have 97.306 meters plus 643.619 meters plus negative 148.454 meters plus negative 579.13 meters, and this will give us positive 13.341 meters. So now the negative error here in latitude means that we are lacking 8.127 meters in our latitude. And for departure, we have here positive 13.341 meters. So this means that we have an excess of 13.341 meters line in our departure. So the latitude side, this one, we will add these corrections to suffice the error of our closure, since we are lacking this value. And for our departure, since this one is the excess, so therefore we will subtract all of this correction. So now we will compute for the correction of each traverse using now the compass rule. So earlier I presented to you the formula that we need to follow in order to compute the correction along the latitude and departure using the compass rule. So first is we will going to compute for the correction we need for latitude. So we have the formula. So for the correction of latitude, so we have correction of latitude is equal to the closure of latitude times the distance over the total distance. So to get our total distance, we just need to sum up all these distances. So we have 368.76 meters plus 645.38 meters plus 467.86 meters plus 593 meters, and this will give us 2075. So this will be our total distance. So let's start from line AB. So to compute the corrected latitude, we have the total closure along the latitude. So we have total closure along the latitude is 8.127 meters. So disregard the sign times the distance. So we have the distance here, 368.76 meters divided by the total distance. So we have 275. and this will give us 1.444 meters. So this is the correction needed for the latitude of our line AB. This will be AB. Next is line BC. So we have line BC. So the correction in latitude is equal to the total closure along the latitude, which is the 8.127 meters times the distance of line BC. So we have 645.38 meters divided by the total distance. So we have 2075, and this will give us 2.528 meters. Next we have line CD. Line CD. So the correction on latitude is equal to the total closure along the latitude. So we have 8.127 degrees times the distance of line CD, which is 467.86 meters divided by the total distance, so 275, and this will give us 1.832 meters. So these are the correction of latitude of our every lines in the closed traverse. So these four values here. So now, how are we going to compute for our corrected latitude? So take note again that since we have negative 8.127 meters, so we are lacking this value. So we are lacking this value in the length of our traverse. So that means that we are going to add all of these corrections. So let's begin with AB. So we have the latitude of AB, which is 355.69 meters, plus the correction for line AB, which is 1.444 meters, and this will give us 357.134 meters. So this will be our corrected latitude. Now, we will also compute for the remaining ones following the same procedure. So we have the length of line BC, which is negative 47.641 meters, plus the correction for line BC, which is 2.528, and don't forget to put the sign of our latitude value. So we have negative, and this will be negative 45.113 meters. So we have here negative 45.113 for the corrected latitude of our line BC. Next is we have the CD. So we have the latitude for CD. So negative 443 meter of negative 443.683 meters, plus the correction of line CD, which is 1.832 meters, and this will give us negative 441.851 meters. So we have here negative 441.851 meters. Now for our line CD, so we have its latitude 507 meters plus its correction, which is 2.323 meters, and this will give us 129.83 meters. So we have here the corrected latitude for line BA, 129.83 83 meters. Now, you can check if we have the correct answer for our corrected latitude. So, if you get 0 by adding all of these distances, it means that if the value of these all distances becomes 0, it means that natanggal na naton an mga an error aton latitude. So we have here 357.134 meters plus negative 45.113 meters plus negative 441.851 meters plus 129.83 meters, and the answer will be the answer is 0. So we have 0. So that means that we eliminated the errors in our latitude. So now let's move on to the departure. So we will compute for the correction needed for our departure. So to compute that, we will follow the formula, which is the correction along the departure is equal to the total error of closure in the departure times the distance divided by the total distance. So our total distance here is 2075. So let's start with AB. So we have here the correction along the departure of line AB is equal to the total error of closure in the departure. So this is our total error of closure, this one. So we have 13.341 meters times the distance of AB. So we have 368.76 meters divided by the total distance, and this will give us 2.377 meters. Next, we have line BC. So the correction along the departure is equal to the total closure, which is this one. So we have 13.341 times the distance of line BC. So we have 645.38 meters divided by the total distance. So we have 2075, and this will give us 4.149 meters. Next, we have the line CD. So the correction along the departure is equal to the total closure. So we have 13.341 times the distance of line CD. So we have 467.86 divided by the total distance, and this will give us 3.008 meters. And next we have line DA. So correction along the departure is equal to the total error of the closure. So we have 13.341 times the distance of DA, which is 593, divided by the total distance. So we have, this gives us 3.813 meters. So these answers, these values, these are the errors. So now let's compute for the corrected departure. Again, take note that the error in departure is positive. So therefore, there is an excess of 13.341 meters in our closed traverse. So in order to compute for our corrected departure, we have to subtract this correction, that we have to subtract these values, these corrections here, to get our corrected departure. So we have the departure of line AB. So we have 97.306 meters minus the correction. So we have 2.377 meters, and this will give us 94.935 meters. Next we have line BC. So the departure of this line is we have 643.619 meters minus its correction. So we have 4.149 meters, and this will give us 639.47 meters. Next we have the line CD. So we have its departure. So we have negative 148.454 meters minus its correction. So we have 3.008 meters, and this will give us 151.462 meters. And for line DA, we have its departure. So we have negative 579.13 minus its correction. So we have 3.813, and this gives us negative 582.943 meters. Oh no, di ngay negative. So we have here the corrected departure of line AB, 94.935 meters. For line BC, we have 639.47 meters. Next is we have the line CD. So its corrected departure is 151.462 meters, and our line DA has the corrected departure of 582.943 meters. So these are the corrected departures for every line respectively. So now, if you want to check if this computation of departure is correct, then you just have to add all of this value, and this should be equal to 0. So let's try to check. So we have 94.935 plus 639.47 plus 151.462 plus 582.943, and this equals to 0. So that simply means that we eliminated the error of closure for our departure. So now that we have the corrected latitude and departure, we can now compute for the corrected distance by using the Pythagorean theorem. So how are we going to do that? So if we have a value of latitude, which we know that it is the vertical line, and we have the value of departure, which is horizontal. So our distance is from this point to this point, this one. This will be the distance. So our distance is from this point, is the connection between this point and this point. So how are we going to compute for our distance? So by Pythagorean theorem, we have distance is equal to the square root of latitude square plus departure square. So this will be our formula. So this is the formula that we are going to use to get our corrected distance. So let's start with line AB. So the corrected distance for line AB, so distance is equal to the square root of latitude AB. So we have the latitude of AB, 359.69 squared, plus the departure of AB, which is 97.306 squared, and this will give us 369.537 meters. So this is our corrected distance for line AB, 369.537 meters. So we will going to compute the remaining ones following the same procedure. So we have BC. So distance of BC is equal to the latitude squared. So we have the latitude for BC. So it is negative 47.641 meters square, plus the departure, which is 643.619 meters square, and this will give us 641.059 meters. So this will be our corrected distance for line BC. So we have 641.059 meters. So for line CD, so distance is equal to the square root of latitude square of CD. So we have negative 443.683 square plus its departure. So we have negative 148.454 square. So this will give us 467.089 meters. So this is the corrected distance of our line CD. So 467.089 meters. And for our line DA, so we have line DA, the distance is equal to the square root of latitude square of DA. So we have the latitude of DA 127.507 square plus its departure. So we have negative 579.13 square, and this will give us 597.226 meters, and this will be our distance for line DA. 597.226 meters. So we will move on now to the computing of our corrected bearing. So our bearing here has been changed since we have now different value for our latitude and departure. So how are we going to compute for our bearing? So our bearing angle here is in this side, which is our angle beta, and this always refers from the latitude or from the vertical axis. So to compute for our beta, for our angle beta, this one, we can use tangent. So tangent beta is equal to the opposite. So our opposite is the departure. So we have the departure over the latitude. So therefore, we can say that beta here is equal, so beta is equal to the arctangent of departure over the latitude. So this will be our formula. This will be the formula that we are going to use to get our corrected bearing. So first we have the bearing angle of AB. So we have the arctangent of departure of line AB. So we have 97.306 over the latitude of line AB. So we have 355.69 meters, and the answer for this is 14 degrees 53 minutes 10.91 seconds. So to compute this, you need to use your scientific calculator. So as for the direction of this bearing, we can just look at the sign of our latitude and departure. So Since our latitude here is positive, then this is north. And our departure here is positive 2, so this will be east. So remember what I have discussed earlier, that north is positive, south direction is negative, and west direction is negative, and east direction is positive. So this one. So we have our corrected bearing for line AB. North 14 degrees 53 minutes 10.91 seconds east. So next we have the bearing angle of line BC. So this will be arc tangent of departure of line BC. So departure of line BC is 643.619 over the latitude of line BC, which is negative 47.641 meters, and this will give us 85 degrees 57 minutes 52.61 seconds. And for our departure, since we have negative latitude, so this will be south. And for our departure, we have here positive, so this will be east. So for our corrected bearing for line BC, we have south 85 degrees 57 minutes 52.61 seconds east. So for our bearing angle of line CD, we have the arc tangent of departure of line CD. So we have the departure negative 148.454 over the latitude of line CD. So we have negative 443.683 meters, and this will give us 18 degrees 55 minutes 16.28 seconds. And for the direction, since we have negative here, so this will be south. And for our departure, we have negative departure, so this will be west. So our bearing, our corrected bearing for line CD is south 18 degrees 55 minutes 16.28 seconds west. And lastly, we have the bearing angle of line DA. So we have the arc tangent of departure of line DA. So our departure for line DA is negative 590 or 579.13 meters over the latitude of line DA, which is 127.507, and this will give us 77 degrees 26 minutes 37 seconds. And for the direction, so we have a positive latitude here, so this means this will be north, and we have negative departure here, so this will be west. So this is the corrected bearing for our line DA. So we have north 77 degrees 26 minutes 37 seconds west. And now this will be our newly computed bearing due to our adjustments. So that's how you adjust a closed traverse using the compass rule.